We're going to look at a case now where a simple requirement looks really complicated if writing SVA until we consider changing what the clocking expression is. So here's a requirement for a simple interface, and again this is not a contrived example, this is from a customer case. So the requirements for this interface were there's two signals, request 1, request 2, and they both must not occur at the same time, so that's easy. Now at every POS clock, check that this condition is not true. We also had the extra complication of a valid signal here, so we're not caring about what the value of rec1 or rec2 are if the valid signal is not true. So we include that in that expression. And we're using the SVA not operator to say the condition we should never observe if there's no overlapping. When rec1 occurs or rec2 occurs, both must last exactly 4 cycles. Rec2 must begin immediately on the cycle following rec1. The pulse of 4 rec2s must follow immediately afterwards. And valid is the thing that makes this a difficult problem. If valid is 0, then we don't care what rec1 and rec2 are doing, and we don't know how long valid is going low for or when, so we've got no idea. It could be any time. So these requirements, apart from the first one in this list, are easy if we did not have to consider valid, but we do. So here's some example waveforms here. So starting at cycle 2, rec1 goes high for 4 cycles, followed immediately by rec2 going high for 4 cycles. Rec1 and rec2 are not high at the same time, so we can consider this transaction of rec1s and rec2s to start cycle 2, end cycle 9. So that's the simplest case. And luckily for us, valid stayed high throughout that. However, when valid starts going up and down, so on this cycle 11, for example, here, we're not caring what rec1 and rec2 are doing because valid's low. So cycle 12, we do care about what rec1 and rec2 are doing, and rec1's high for 1, 2, 3, 4 cycles. The cycle following that, we expect rec2 to start, of course, unless valid is 0, which it happens to be. So at cycle 16, rec2 is 0. Rec2 occurs the next time valid occurs, so that's okay. So we get 3 occurrences of rec2 consecutively. Then valid goes low again, so we're not caring about rec1 and rec2, so it's okay if rec1 goes high, for example, just gets ignored. And on this cycle here, 22, the transaction finally ended. So there's an infinite number of variations upon that, which makes it hard. And in fact, it's probably impossible to actually code some SVA that actually does that check. However, if we make one simple consideration, can we make things easier for ourselves based upon when we actually sample the property? So what we can do is use this IFF operator. Okay, so this is not just for assertions, this is, in fact, its original intent was to describe a flip-flop with a clock enable. So here, instead of saying that POS clock for our properties, we say if and only if valid is true. So basically, we turn the clock off if valid is not true. So this consideration now, this property, if we got this IFF valid, we just say not rec1 and rec2 for the first requirement. Second requirement, we say if we have a rise of rec, so we could have more efficiently used rows of rec1 here instead. So if we see the rise of rec1, then we must see rec1 for 3 cycles followed by not rec1. All sampled only when the clock occurs and valid is true. And likewise for rec2. So we could have been even cleverer here, couldn't we? We could have made a parameterizable property in the first place, and the parameters we pass in would be just the different signal names. You know, pass in rec1 for this instance of a property and pass in the signal name rec2 for this instance. Otherwise, they're both the same thing. These don't check, of course, that we have rec2 starting in the cycle immediately after rec1, so we need another property to do this. So we define a sequence with a name, so our named sequence is 4 consecutive occurrences of rec1. So consecutive means consecutive occurrences of POS clock with valid being true, and likewise for the signal rec2. We could have, again, made this more efficient by defining a parameterized sequence and just passing in the name of the signal again. We could have saved ourselves a lot of work, a lot of repetition. And what we then say is, if we have this sequence of 4 rec1s, what must follow the next cycle is 4 rec2s. So what was previously an intractable problem is now easy because we think about using a different clocking expression and using this IFF to indicate the situation under which we allow the clock to tick. Thanks for listening, and hope you found that useful.